Hey everyone, this is Andrew. Welcome back to another episode of my C++ SFML game tutorial. In this episode, we're going to build off what we did in the previous episodes with our tile map and our physics system and combine them together to sort of get a groundwork for a sort of tower defense-like system. So right here is the end product where we can go into this editor mode and it's expanded. So now you can set a spawn point and a path to the end, and you can additionally have multiple different paths and the enemies will choose one and go towards the end. I think this is a really fun start to a game project, and it's fun that everything is physics based. So the enemies bump into each other. When we add towers in the future, they'll get to knock enemies over. And there's just a lot going on here that's fun to explore and play with. So if you're interested at all in this sort of stuff, I really encourage you to stick along with this tutorial until the very end. Thanks so much for stopping by. It really means a lot when you guys comment on my videos. And if you like it, leave a like. If you want to see more, subscribe. And yeah, I'll kick it over to the tutorial now. Thanks so much. Hey everyone, this is Andrew and welcome back to another episode in the SFML tutorial series. Just going to take a quick look to see where we left off last time. I think we worked on some pretty basic collision, and we have the level editor. Yep, there's collision with the level editor now, and you can like hit the enemy with your axe. And so today I'm going to continue working on this project, and we're sort of at the point now where we need to decide what this game is going to be. Because we're sort of almost building a game alongside essentially what you'd consider like a very lightweight game engine. And I think one of the biggest advantages of rolling out your own engine is that you don't have nearly as much overhead as if you were using some sort of prefabbed engine like Unity or Unreal. So we do have some bonuses that come along with that, like catering our engine to exactly what our game needs. We can squeeze as much performance out of it as possible. Okay, but without getting too crazy, what I've decided to do for the game to sort of drive the development of this series along is make a little tower defense game that is also physics-based. So we'll have enemies flowing in from one side, going out the other, and as you throw projectiles at them or traps or whatever we end up doing with our towers, the enemies will get knocked back and knocked around and stuff. And I think that'd be a fun little twist on tower defense games. I think for the most part, there aren't too many physics-based tower defense games. And then additionally, instead of leaning in on sort of like level design and everything, I'd like to really just focus on making a nice level editor so we can make fun tower defense levels. And then eventually I'll add in support for saving the levels and loading the levels. And I think that'll be a really nice end point for the series where we sort of get into a spot where maybe we've like really ramped up this level editor. Anyways, I think that'd be a good spot or a good goal for the series is to just end up with a really robust level editor for making tower defense levels. And then maybe at the very end, I could design up a couple levels and just chain them together and call it a game. But yeah, so just to start off, my goal for today is to have enemies spawn. Well, what I'd like to do is something like this. So we have this level editor. Am I in level editor mode? How do I change the tile I'm using? I thought it was scroll wheel. Oh, it is scroll wheel. There we go. So, because it's like 16 tile. I totally forgot about this. Okay. So what I'd like to be able to do is do something like, we'll make red be like, this is the start tile, green be the end tile, and then do something like, we'll make the blue be the traversable tiles for the enemy. And maybe there's two paths to the end. So you could do something like this, and then like this bricky concrete look. That would be where the player could place their tiles, and maybe we use white for like out of bounds areas. Like you can't place tiles here. Maybe you can't place tiles there. something like this. And then what I would like is this to translate into like a tangible game. So once we exit level editor mode here, the enemies, which are just skull images right now, will spawn at the red tile and they'll start moving towards the green tile. And that's it. I just want them to spawn at the red tile, move towards the green tile. If there's multiple paths they can take to the green tile, I'd like them to like divvy up the path that they take. And then when they reach the green tile, they'll just disappear. And that's it. And then additionally, I'd like to make this sort of as robust as necessary for this step, where in level editor mode, we can just say like, hey, we can detect errors. So let's say that this was a blocked off here. In level editor mode, we'd say, hey, like this is not a valid level. You know, the guys that spawn in here will never make it to the end. So you need to change it. And then right when we add this blue tile, let's say like, yep, this is a good level edit, or this is a good level mode. We can let this happen. So let's exit out of the game and start coding this. And my idea so far with coding this, if you recall how we're dropping down the tiles currently, let me see here. It's been a moment since I've done this, but yeah, so right now our tile options, and the tile options are just the sprites that we're showing when you use the scroll wheel. So when you scroll through them, that's another thing. I could probably just go look at the tile options. It's just a picture or a PNG. So if I go into my images, yeah, here are my tiles. So I have this tile map, and right now it has, zoom in a bit here. Right now it has, you can kind of imagine it's 16 tiles, but only the top 4 are filled in. And what I'd like to do here is, instead of it just being a sprite that we're cycling through, I want the tiles to have some tangible meaning, and maybe even have the tiles go onto different layers. So for instance, when I was displaying in the game before, I showed that the red tile, that's where I want things to spawn. But that's really just contextual information. You don't actually, when you're playing a tower defense game, it doesn't actually have a red square that says, this is where the enemies spawn. It just is what it is. Maybe the designer put a red square there, but it's really just for us when we're editing the level. It's convenient to see that, but the end user probably wants to see some sort of, nice little graphic there. So what I'm planning on doing is changing this red tile to say something like spawn, the green tile to just say something like end, and then when we're in the tile editor mode, we can place those down, but then once you're in the game, it'll vanish and it'll just work how we want it to. Okay. And to do that, more or less, my idea right now is to abstract our tile options into their own little thing. So right now it's just a sprite, but we could change it to a tile option class. And yeah, let's just get started doing that. Sorry, I put my hand over my mouth. All right, let's get started doing that. So, x64, why am I in this sort of view? I hate this sort of view. So if you click this switch between solution and available views, I think you'll get a better view. Is this what I want? Not really. Okay, not super important. I'm just going to right click here, click new class. I'm going to call this I'm going to call this a tile option. One second. I'm going to call this a tile option. Click OK here. We have this tile option. I'm going to change this pragma once to just be a def guard. So if not defined tile option, define it. And then an endif here. And then inside of my game, I'm just going to drag this to be on the other side so we can see a little bit better. And I will additionally just include this up top. So we'll say include tile option. And then sort of like I was saying before, is that I don't want the tile options to be a list of sprites. These need to be entities. Go away to do. We're changing it. instead of this being a list of sprites, we're going to have this be a list of tile options. And then let's go see what kind of implications that'll have on our code. So if I go look for our tile options, okay, yeah, we're going to want to be able to do things like, because previously it was a sprite, so you had things like set position, and you could just draw it directly. What else could you do with it? Oh, we were able to copy it directly to a sprite. Okay, this is all fine. Then we had tiles. Oh, and then at the beginning, we were iterating over all of our textures and putting it in. So we were just pushing it back directly. We were making a texture from that. Okay. Yep, that's fine. So what I'm going to add here is, nope, we don't need any of this. Sorry. I'm going to add a constructor. I'm going to make the constructor public. And then I'm going to start off by just adding a SF sprite as a member variable. When you're starting an abstraction like this, it's a good idea to first, before we go any further beyond from a tile option being more than a sprite, to just get back to a place where it was previously working. So I've just changed SF sprite to tile option. I've made this class tile option. I've added sprite as a private member variable. And what I'm going to do is just make sure that everything still works how it used to and build out that sort of functionality. So if we go to game, we'll see a lot of red squiggly lines here. So for instance, at the beginning, when we were building the tile options, all we needed to do was have a tile, but now we're actually going to have a tile option. And so might as well just change the name to tile option. And then we have all these things in here that we were previously doing on the sprite, like set texture. So what we can do here instead is we can say, well, we could actually just let it set the sprite. It's not a terrible idea. So if I just keep this as a sprite, and then I set the sprite's texture, rect, scale, origin. Okay, that's all fine. Then below we add a tile option. I say tile option. And then in here, we can just have a function called set sprite. And we can just set our sprite to be equal to the sprite that was passed in. And then we'll have a tile option. We'll go tile option dot set sprite, and we'll set it to what we previously had. And then remember, this vector of is a vector of tile options now, not a vector of sprites. So we'll push back the tile option. And yeah, that's fine. We can just do that for now. And then we don't do anything in our constructor. So I'm just going to change it to, or set it to the default constructor now. Let's keep going through this. So when we're drawing the level editor, we're calling set position on the tile option. So we can change that. And here we can add a set position function that takes in a vec2, and we'll just set it directly on the sprite. Now that'll be happy. And then we want to be able to draw it. So just like we did before with the entities, if you remember, we can make them derived from this drawable class. And what that allows you to do is define this draw function. So we'll do that here. And then the draw function, we can just draw the sprite that's inside. And what that lets you do is when you have a window, you can just call window.draw and just pass in tile option directly. And then because it derives from a drawable, then the window will call draw on the tile option, which just draws the sprite. So it's a little roundabout, but it lets us keep the same looking code, which is really convenient because in the future we could change this draw class, or I'm sorry, the draw function inside of tile option without changing the surrounding code that does all that hubba bubba. So here we go. We can also just add a get sprite function. So we could say, what do we want to return? Probably just a copy of the sprite. Or we can return a const ref. That's also fine. So we can't just say sprite equals tile option. We can say get sprite and just copy it. And this might be all we need to do to get the original functionality back. So just a quick recap, what we've done is we've changed our tile options from just being a list of sprites to being a list of this new class called tile option. And all this new class does right now is it just adds a couple of functions that wrap around this sprite, but we'll be able to extend it. We'll be able to extend it really quickly, or just in a little bit. Okay, so here we are back in the game, and we have our level editor, and everything seems to be working pretty much exactly how it was before. So I just drew some stuff, go back into play mode, and yeah, it just it works exactly how it used to. So fantastic. And then in my head, how I'm starting to think about this is there's different types of tiles I would like to represent. So I think, for instance, we had that spawning tile, and the spawning tile has nothing to do with physics. It has nothing to do with what we want to see. It purely has to do with gameplay, as opposed to something like just an aesthetic tile, which is maybe the brick tile. And I think it's a good idea to have this like very strong delineation between what the tiles we're drawing do. I think it'll ultimately end up just resulting in a very simple system to draw levels. So instead of having to maybe like switch between modes and say, hey, I'd like to put down the starting point and put down a starting point, and it's just like a little point in space, or like this is the ending point, or draw areas where, hey, this is where you're allowed to drop towers or not, or even tightly coupling what your tiles look like versus where you're allowed to put towers. I think that smashing all those together not smashing all those together. I think that making those all come from different systems will ultimately be confusing and just require a lot of work, where instead we can just do everything with tiles. So we'll always be drawing tiles in the level editor for gameplay. So if you want to draw the spawn, where things spawn, it'll be a tile. You want to draw where things end, it'll be a tile. You want to draw the path that enemies are allowed to follow, that'll be drawn with tiles. You want to draw the just aesthetic things in the game, that'll be tiles. You want to draw where the player is allowed to put down towers, that'll also be tiles. And because we're doing everything in the same system, we'll have less code. And I also think it'll just be easier to work with because we won't have to have as many interfaces for the user to pan over to make a level. So I know that's a lot of kind of just blabbing on. So it's hard to really get an idea of what's in my head unless we just code it up. So before I do anything else, I'm going to open up my tile map in GIMP, and I'm going to add, just open up my other monitor. Don't need that. That's fine. Okay. The first thing I'm going to do is I'm going to add a couple new tiles. So let's go into GIMP. I'll have a link in the description to download GIMP. If you don't have it, it's just, it's a free image editor. It's pretty nice. Gets the job done. So first go set the spacing, then show the grid. And then what I would like to do in this tile is, and this is purposely done this way because we're not going to see this in the game, I'm going to write SPW for spawn. Gosh, that is just miserable. Maybe I should type it. Okay. Spawn. Oh no, it's going to type in this massive font. How small can font go? Let's find out. No, let's not find out. This is getting out of control. Okay, I'm going to draw a big S for spawn. Then I'm going to go to the next one. And I'm going to draw a big E for end. This is where everything spawns, all the enemies spawn. This is where they all need to end up. And then I'm going to go one more, and I'm going to say a big P for path. And I think that's all we need. We need a spawn, we need an endpoint, and we need a path. And then these tiles all up here will all be aesthetic tiles. That's probably fine for now. So what I'm going to do is just save this. I actually don't even need, let's just export it as tile map. Export that, export, good. Okay, close that. So now we have SEP. So if we fire up the game again and I go into tile mode, I will see SEP. And my goal here is to do something like this. This is what I would like to functionally happen. I type S here, I type E here, I put a path in between them. I think it's interesting to have multiple paths. And then ideally, we probably have a mode, excuse me, where we hide this path, or maybe the path turns into like a different tile set in the game, because we don't actually want to see this when we're playing the game. And then you'd be able to draw in these tiles, blah, blah, blah. And then when we exit tile mode, I would like the enemies to start spawning at spawn, going towards E, and I think that'd be a good place to stop once we get there. So we're obviously not there right now, but we do know that we want the tile options to, the tiles to represent different types of things. So what I'm going to do is add an enum here, and I'm going to call it, we could call it tile type. It's not, yeah, tile type is fine for now. There might be a better name for this, but I'm not going to worry about it too much. And I know there's a couple of different types of tiles we want. We want aesthetic tiles. We want a spawn tile. We want an end tile. And we want path. And these are for sure things that we want. And then in our game, when we're adding the tile types, this is where it gets a little bit unfortunate because it's just sort of hard-coded right now, but it is what it is. So we're looping through the Y's and then the X's. So we'll go X is 0, Y is 0 first. So these first 4 tiles that we go through, the first row. So if, and let's also add this tile type, and just, I like adding a null type at the start, just so you know if something hasn't been initialized. So we'll add the tile type as a private member variable, and then in the constructor, which we'll add now, just a little baby constructor, in the initializer list, we'll say tile type is null, and then we'll add actually, probably a good way to go about it is to just pass in a tile type into the constructor. That way it gets set. It gets set when we create the tile, or sorry, it gets set when we create the tile option, and then it never changes. And in order to do that, we need to put the enum above the constructor, or else it won't know what tile type is. And then we can just copy this little bit into the constructor here. And then instead of initializing it to null, we'll initialize it to whatever it was passed in. And we will say, so instead of saying push back, I want to call in place. So we will say tile option equals m tile options dot in place back. And what in place does is it lets you pass in the arguments to the constructor of whatever you're making. So in place back here, and then it's going to return a reference to whatever we just inserted. So what I'd like to pass in here is the tile type. So we'll have tile option, tile type, and and then we'll say tile type, and we'll initialize it to null. We'll pass it in here. And then once we add that tile option, we're going to set the sprite just like we did before. And then additionally, we'll say if y equals 0, and y equals 0 will be this first row. Whoops. If y equals 0, we'll say tile type equals tile type aesthetic. Else, if y equals 1, and this is our second row right here, we'll say if x equals 0, tile type equals tile option spawn. So that's when y is 1 and x is 0. And remember, 0, 0 is at the top. So, and we move down. So y is 1, x is 0. That's our spawn tile. And then we'll say else if x equals 1, it's the end. And if x equals 2, it's the path. And that's all we'll need to do. So now our whole tile list gets added together. I'm sorry, all of our tile options get pushed back just like they did before. They still have the same sprites they did before, but now that first row tiles all have a tile type of aesthetic. The second row of tile, the one with the big S, has a tile type of spawn. The one over from that has a tile type of end, and the one over from that, and we should explicitly say this for x equals 2, has a tile type of path. Okay, very cool. And then I really highly encourage this when you add something like this. I know it doesn't change the game at all, but it's a good idea to just run the game. Does it still work how you think it should work? If it doesn't, that's a problem. So you should definitely sort that out. And it seems to work fine. Now, the next thing I would like to do is, if you recall, let's just look here real quick. We have this list of tiles. So when we left click mtiles dot, when we create a tile at position, we click. So this probably gets called when we click with the left mouse. So we click with the left mouse button. And what we're doing, I'm just speaking out loud to remind myself. We click with the left mouse button. We grab this sprite from the current tile. We set its position based off of the XY. And then we iterate through all of our tiles. And if it's at the same position, we replace it for, well, first we delete the tile that's there. So that's the first thing that we do. And then we replace it with this new tile. And we're just setting the sprite. And we're setting the rectangle physics there. Cool. Okay. I don't mind that at all. Okay. So this is all good. So what I would like to do instead is I would like to, instead of having just a list of tiles, I am going to do some trickery here. So I'm going to set the tile type, the first value in it. And you can do this for enums. So enums, they just count up from whatever you last set them to. So I'm going to set the null value to -1, which means aesthetic value will be 0 and spawn will be 1. And this happens automatically, so you don't have to actually explicitly set this. But what it does allow me to do is it allows me to say num tile types at the very end. So if you're counting along, this would be 0, this would be 1, this would be 2, this would be 3, and this incidentally will be 4. And what's convenient about that is 4 is the number of types that we have. And this only works when you add a null value if you set null to start at -1. So instead of having just a list of tiles, a vector of tiles, I want to have a vector of vectors of tiles, and the number of vectors of tiles I want to have is the number of tile types. So that was a huge mouthful. To break it down, the idea is that when I add an aesthetic tile, I only want to check and replace other aesthetic tiles. So that will allow us to do things like this. We can set a tile as a spawn type, and then we can put an aesthetic tile at the same position, which makes sense because I've been talking this whole time that we'd like to get rid of that that spawn tile, which is just a big S right now. So instead of having just a list of tiles, or actually maybe a simpler way to go about this is I'll just have, maybe this is a little overkill. It's not directly overkill, but just for the sake of the tutorial, let's start with something a little more objective. So I'm going to rename this to aesthetic tiles. And then additionally, I'm going to add 3 more, and they're obviously not all going to be named aesthetic tiles. I'm going to name them after all of our tile types. So we're going to have spawn tiles, end tiles, and path tiles. And then when we go, so we say create tile at position, and right now we're grabbing this tile and then we're iterating over aesthetic tiles. What I want to do is I don't want to necessarily iterate over aesthetic tiles. What I want to do is iterate over whatever list of tiles is equivalent to the tile option I'm going to put down. So I'm going to add a little helper function called, it's going to return the tile list that I want. So it's just a vector of entities. It's going to be a reference, but it's not going to be get aesthetic tiles. Oh, sorry, cat feeder just went off. It's going to say get list of tiles. And what it's going to take in is a tile type. Call this eTile type. And let's go make a function definition for here. So we're going to add a switch statement on the tile type. Wow, I really misspelled that. Tile type. And we'll say when we have the aesthetic tile type, we want to return the aesthetic tiles. And when we have the spawn tile type, we want to return the spawn tiles. And then for the end type, we return the end tiles. And for the path type, we return the path tiles. And then at the end here, this would be where you would probably add an assertion because you've asked for a tile type. Well, yeah, what do we want to do? We could add a null path tiles. A little awkward though. You probably don't want to do that. Actually, I think a good way to prevent this from happening right now is that when we're going to create the tile, we can say, so I'm going to start off here and we're just going to handle the null case directly. So what we'll do is we need to get the tile option tile type from the current selected object, or the current selected tile option type, and we need to add a helper function, get tile type. We need to add a helper function to our tile option to be able to get the tile type. So I will add a tile type, get tile type. Nice. And we'll just say if the tile type is null, just return. We're not going to do anything with that. We don't care about it. And then the next thing that we're going to do is we're going to get the correct list of tiles. So we'll say standard vector of entities, list of tiles, and we want to get, what did we call the function? Did I call it get list of tiles? Get list of tiles? I did not. What did I call it? Oh, I did call it get list of tiles. Why did I not find that? Cool. Okay, get list of tiles. And we'll get the list of tiles that's associated with that tile type. So just to quickly give a different perspective on what we're doing here, in case it's a little hard to follow along with just me chatting in the code, is that when we go to place a tile, so we want to place this into our game world somewhere, the first thing we're going to do is check out what kind of tile is this? And if it's just an aesthetic tile, which means that we just care about, we're just adding this tile to the world because it looks good, the first thing that we need to do is we need to find the associated list of tiles that is our list of aesthetic tiles. So internally we have these 4 lists of tiles. They're the aesthetic tiles, they're the end tiles, the spawn tiles, and the path tiles. So the first thing we do is we say, what type of tile are you? This is my question mark. And then this function here, get list of tiles, will say, okay, you're an aesthetic tile. We need to give you this list. And then we push that list back out. And then we're able to use that list to first find, okay, are there any tiles that are at the same position? If there is a tile at the same position, we're going to remove it. And then we're going to insert our new tile there. And the nice part is this middle section right here. This is an abstraction so that we can utilize the same function at the end, create tile at position, without having to have a create aesthetic tile at position, create spawn tile at position, create end tile at position. Instead, we can just say create tile at position, and internally we'll make sure we're doing it on the right list of tiles. And then the only thing we need to do here is, instead of iterating over aesthetic tiles, we'll just iterate over whatever list of tiles was returned. Okay, very cool. And then I think I had like a delete tile at position. So we have to think about this a little bit. For deleting the tile at the position, it is a little complicated, but I think what I would like to do is we'll delete the tile type that you have currently selected at the position, which is maybe, I'll be candid, is maybe a little bit confusing. I think a better approach would be to like explicitly ask the user what kind of tile they would like to delete, rather than it being inferred from the tile type. But that's what we're working with right now, which is no problem. That's okay. We know we're we're not gonna have perfect software at any point during this, so it just is what it is. So we can do the same thing we did when we created the tile. So we'll get the current tile type. If it's null, we'll just say nope, ignore it. Else, we're gonna get the list of tiles associated with the current tile type. We're gonna go iterate over it. If we find there is a tile at that position, we're going to delete it. No problem. And now the only thing that should say aesthetic tiles in this function is just the end there. Oh, update physics is just going on the aesthetic tiles. This is actually probably okay. And this is where our abstraction starts to show why it's useful. So we have all these types of tiles, but the only one that we really want to impact gameplay is these aesthetic tiles, which, now that I'm saying it, is probably not the perfect name for it, because aesthetic kind of implies that it's just for looks, but it actually is also for physics. Whoops, but no problem there. The other thing I have right now is that when we're drawing the tiles, we're only drawing the aesthetic tiles. But what I would like to also do is, I think I would like to check what game mode we're in. Oh, we already have this set up. Fantastic. So when we're in the level editor mode, right now we're drawing the current tile option, but I would additionally like to draw all of the spawn tiles, path tiles, and end tiles. So let's do that here. So it's going to be very similar to this code where we iterate over the entities in the aesthetic list, but instead I'm going to iterate over the entities in the spawn tiles list. And then I'll iterate over the end tiles and then over the path tiles. So let's just say that, draw spawn tiles. I know this is probably not necessary, but draw path tiles. And now if we run the game, fingers crossed. Okay, so we're in the game here, and I've just gone into the level editor mode, and now I should be able to draw with aesthetic tiles, no problem. And then if I draw something like a spawn and an end, and let's just draw a path straight across, and then I leave level editor mode, you'll see that we're no longer drawing that because we only draw it in level editor mode. Additionally, when I right click to delete, it doesn't delete anything unless the tile type matches, and that means literal tile type. So if I went to the blue tiles, I could still delete, sorry, I just ran. I could still delete these brick tiles because they're the same tile type, which is aesthetic. So I'm going to put these brick tiles back. And if I wanted to delete something like the spawn tile, I'd have to be on the spawn. So I can't delete the end or the path tiles. The only confusing part right now is that you can draw multiple end tiles. And for instance, I have an end tile drawn underneath this path tile right now, but you can't see it. So this is the kind of error correction that it would be nice if our game built in. So maybe as like a very simple example of this, we could start off by saying maybe we should only have one end tile and one spawn tile. So when we go to place a spawn tile or an end tile, we can just start by clearing all of the existing ones, and then letting the new one get placed down. And then additionally, yeah, we could add some other stuff in, but I'm going to hold off for now. So the one thing I am going to add is that when we add a create tile at position, I just want to say, so we get the top list of tiles, say if e tile type equals tile option tile type spawn, or why can I not spell tile? So my brain totally fudges it up. Or e tile type equals tile option tile type end. So if we're creating an end or a spawn tile, then I just want to clear the list of tiles because we only ever want one spawn or end tile for now. And now if I go back in and show you that, when we go to the spawn tile and I click it, it just deletes the spawn tile that was there previously, which is, I mean, it's sort of, it's not completely necessary. We could have the user delete the tiles that they don't want if there's duplicate tiles, but this is just sort of easy quality of life for us right now. So let's start building a little bit of our gameplay around these tiles. So the first thing I'm going to do is go look for the enemy. And let's think about abstracting this a bit. So we have this enemy here, and it's just an entity, if I'm correct. Just an entity. Let's go look at entity. Cool. Cool. Yep, pretty straightforward. We're setting its textures, scale, position, origin. We set the circle physics on it. And I think at some point we're drawing it and we're updating its gameplay. Oh, we're just setting its velocity. Cool. And then, yup, we draw it, update physics. We are just going over it. Okay. So what I'm going to do instead, enemy is totally fine. We can leave enemy here. One little addendum. If you look at our tile size and you look at our enemies right now, the enemies are pretty big. So I'm going to make it 1/4 of the size for the actual gameplay. Because right now, if it's the same size as the block and we make this a physics-based tower defense game, when you're knocking the enemy around, there's really not much room to be knocked around if the path is approximately the same width as the diameter of the enemy. So here we're going to set the scale to 5 and 5. Origin's fine, and then the physics will also need to be cut in half. And then if we run the, and then if we run this, we can see, okay, now we've got this little tiny guy. Very cute. Should still work though, the physics and everything for it. And it looks more or less fine. Cool. All right. And then the last thing I'd like to do is have enemy move towards player. Let's not worry about this for now. So we're not going to update the enemy physics anymore, and we're not going to draw the enemy. Actually, before I get ahead of that, let me tell you what I'm planning on doing. So instead of just having an enemy, because this is a tower defense game, at some point we'd like to have lots and lots of enemies. So where I'd like to end up is with having many, many enemies. So this first enemy that we have right now, I'm going to just change it to be an enemy template. And then I'm going to add a vector of entities, and these are going to be the real enemies in the game. So this is what I want to draw. This is what I want to update all the physics on, and so on and so forth. So for instance, here, instead of updating the physics on the enemy, and I changed its name so we know where silly things are happening. So instead of updating the physics on the enemy template, what we want to do is we want to say for entity not spawn tiles in enemies, we want to push back the, and I like saying what things are, so we're going to push back the enemy, and then we don't need to update the physics on the template, obviously. And if we look for other places where we do the enemy template, so right now we're drawing the enemy template. We don't need to be doing that anymore. Now what we need to do is we need to go through, I did spawn tiles again. Enemies, enemy. We're going to draw all the enemies. We don't need to draw the enemy template anymore. And then let's look for, enemy template. Holy cow, I can't spell today. Template. Okay. For more spots. Okay, then when we're updating the gameplay, previously we would find enemy to player, and we would set the velocity. And this is going to be totally different now. I don't need that there. And this is going to be, different in a way that like what our game has changed. We're not trying to have the enemy run towards the player anymore. What we want the enemy to do is go along the path to the player, which we don't have a path yet. So let's just not worry about this. I'm just going to comment this section out just so we can keep coding. So gameplay, cool. Any more enemy templates? That might be it. Okay. And then in our gameplay, what we want to do is say something like, if I'm just going to write some code here. Actually, this is probably a good time to break out Sublime. So we're going to have, and we can just ignore all these random numbers here. We're going to set in our game some max number of enemies. And then when we update the game, we'll say if the number of enemies we have is less than the max, then we need to spawn an enemy. And then additionally, we need to say for each enemy in the game, set its velocity to the next, to point towards the next tile in the path. And yeah, and then finally we need to say if the enemy is at the end, delete them. And more or less, this is what we want to do. And then you could imagine that in a tower defense game, if the enemy is at the end and we delete them, we would do something like also subtract 1 life from the player. And maybe the maximum number of enemies, increases over time. Stuff like these. This is like, that'd be game design stuff. So we can leave that up to a homework problem if we want to, but let's get these 3 steps in here for now. So I think this one is going to be the most complicated one, which is making sure that we have a path. And how do I want to do the path? Okay, I've been thinking about how to do this path construction for sort of a long time now, so I didn't record me writing the code, but I'm going to go over it now. So I'll also launch the game really quickly just to illustrate why this ended up being more complex than I maybe thought it would be to begin with, which is mainly just a symptom of, I'm thinking of how this path is actually going to be used by the enemy. So let's say we have the path start here and end here, and the path will go straight across. But additionally, I'd like to have this long outer loop that enemies could potentially go through. And all the ways I was thinking to implement the pathfinding gets a little tricky when you're trying to resolve which direction to go on your path. So for instance, let's just pretend like this blue, let's pretend like this S is the enemy. So the enemy spawns here, and if they just go straight, it's pretty simple. They can just keep going ahead. And if we know the distance from the start, we can always just go up 1. But when we get here, it's a little more tricky because this tile to the north of us would have a very large score because it takes so far to get to. But on our pathfinding, maybe it actually is not a large score, so we might even consider going up north instead of just going east to the end. And if we go straight ahead and we go up north, you see that we've kind of caught ourselves in a loop. If we've gone north here, the only way to go is to go all the way back down and then south and then back over here, and we've found ourselves in the same position that we began with, which is not how we want this or expect this to work. I think that when you're looking at this sort of path layout, the 2 expected paths are they spawn and they go straight across, or the enemies spawn, they go up north, over, down, and then to the end. So I've been thinking about this a lot. I tried to implement a couple ideas, and I really wanted to avoid recursive functions, but the solution I ended up with does have a recursive function. And sorry, I'm actually going to bring this up again. And the idea behind my solution is this. We're just going to keep track of all of the valid paths. And when an enemy spawns, it's just going to pick a path and stick to it. So it's actually a lot simpler in this sort of structure to say, hey, we actually have two paths. We have this path that goes straight across, and we have this path that goes up and around and down and back over. And what we're going to do is we're going to save these two paths. So we're going to save this blue path, which we know makes it to the end, and we'll save this green path, which we know makes it to the end. And then when an enemy spawns, I'm just going to give them one of these two paths to follow. So now we need to get on to constructing the paths themselves. And I will say this is definitely not the most efficient way of constructing these paths. You'll see that there's a lot of copying going on, which is something that we generally try to avoid. But I would say that because of how we've structured the game, in the sense that this is a level editor mode, in theory, you don't need to really worry about the complexity or slowness of the level editor, because once you have made the level, you should be able to run the pathfinding algorithm to produce all of your paths and then just save those paths. When a player goes to play the game, the paths will already be generated. It doesn't matter how long it took you to create them. So I'm not going to fuss over time complexity of the algorithm right now, or space complexity, since it's recursive and we're copying a bunch of vectors. So just to take a look with what I've done, I've added this pretty vanilla struct called path tile, which is maybe not the best name because I also have a vector of path tiles, but anyways, I digress. What it is it's a current tile, and it just points to a next tile. And what that means is it's always a linear path. You know the next tile you need to go to. There's no ambiguity there. Then I've added this type def, and the type def is really just so I don't have to look at vectors of vectors. It's vectors of paths, which makes more sense to me in my head. But a path is just a vector of path tiles, and then our game is going to save a list or a vector of paths. And then when an enemy spawns, we can just give them an index to which path they're going to use, or we could copy it over, whatever we want to do. And then I've added some helper functions here. Visit path neighbors and does path contain coordinates. Additionally, I've added this function called construct path, and construct path is called every single time we add a tile in the level editor mode, which is maybe a little overkill. You might think, well, what if we're adding an aesthetic tile? We're going to construct the path again, which is true, and we're just going to live with that for now because it's very simple. And then in my entity class, I've added one additional helper function called get closest grid coordinates, which just takes the position and it turns it into a simple XY that just increments by 1 as you go left and right across our grid map, which is just more a little intuitive when you're building the algorithm, so that I don't have to say, hey, the tile to the right of me, do x plus 160. Instead, we can just say the tile to the right of me, do x plus 1. The tile to the left of me, do x minus 1. So let's take a look at the functions I've made so far. And I haven't verified that they work, so bear with me. But this construct path function, the first thing we do is we take all of our existing paths and we clear them out. The second thing that we check is, do we have a spawn tile and do we have an end tile? If we don't, then we can just quit out immediately. We could probably also check, do we have any path tiles? But I suppose technically you could make a path with just a spawn tile and just an end tile if they're right next to each other. The next thing that we do is we start a new path, and we set the first tile in the path to our start tile. So we set the pointer to the current tile to a reference to the 0th index of the spawn tile. And remember, we'll only ever have one spawn tile because every time that we add one to the list, the first thing that we do is we clear all the existing ones. And then finally, just for convenience, I'm keeping track of the coordinates of the end tile so that we know when we're done with our recursive algorithm. And then here comes the recursive bit. So we have this path, and if we're just, maybe I'll draw it in paint just very briefly. Here's another drawing. I don't know if I'll go over this drawing, so I'm just going to start a new one. Don't save. We have our starting tile. This will be the starting tile. make this real simple here. We have the end tile, and then we're going to have this alternative path up here, which is a little longer and out of the way, but would still be cool to see enemies go to. So we start off by just adding this tile to our path. And the next thing that we're going to do is we're going to call visit neighbors. Let me make this a little bigger. And there's 4 potential neighbors that we could have. We're going to check in all the cardinal directions. So we're going to check north, east, south, and west. And how I've gotten the coordinates for those is I've just grabbed the coordinates of the current tile, and then I'm either subtracting 1 from the y value, adding 1 to the y value, or subtracting 1 from the x or adding 1 to the x. And this is what I was talking about earlier, where using the closest grid coordinates just makes this a little bit more intuitive. The next thing I'm going to do is I grab the list of all of our path tiles, and I iterate over the list, which means to say that I look over. So let me just, I'll just color in the path tiles real quick. So these are our path tiles, all of these ones that I just drew. These are our path tiles. And for the sake of our game right now, the end tile is a path tile, and the start tile does not have to be a start tile. I'm sorry, does not have to be a path tile. So we're going to iterate through all of these path tiles, and we're going to say, first of all, does my path already contain your coordinates, which is just this little helper function here, which goes through all of our existing path tiles, and it grabs our coordinates and just compares them. And if it does contain it, we return true, else we return false. So that's just a quick one to prevent any loops. You could imagine, I'm going to draw one path here real quick. Let me get my brush, make it a little bigger, and draw one potential path. So let's say we start, that's a terrible color. Let's go with blue. And can I make this a little bit thicker? Do I have a thickness here? No. Okay. Let's say we start going down this path, and we go north, east, south, and we go back over here. When we go to visit this node, we'll say, oh, we've already visited this node. And in fact, we have no more nodes to visit, so this is not a valid path. And this is mostly what the algorithm does. So we would do this and say not a valid path. It would also go this way and say, hey, this is a valid path. Additionally, it would go straight across and say, hey, this is a valid path. And then finally, it would go straight and then up and over. And it would say, we have visited this node and there's no more nodes to visit, so this is not a valid path. All said, we'd check 4 paths. 2 of them would be valid and 2 of them would be not valid. And so let's see how we do that exactly. In here, remember, we're iterating over all the path tiles. We say, first we get the path tile as coordinates, as grid coordinates. And then we say, are you the tile to the north, east, south, or west of me? AKA, like, are you a neighbor tile? If you are a neighbor tile and we get here, this means that you're a neighbor and we haven't visited you yet. Set. We haven't visited you yet. So what we do, and this is the part that's a little bit not efficient space-wise or speed-wise, but it does make for a pretty convenient and short pathfinding function, is we copy the current path and we append the tile that we just visited, which is right here. And then what we do here, and this is sort of the step in our recursive function that lets us exit out, is we say, hey, is this tile that we just added the end coordinates? If it is, then this path reaches the end and we can just add it to our list of paths. If it does not reach the end, then we're going to visit all of the neighbors. So just to run you through an example of how this would actually work is as follows. So we add the start node, and then we call visit neighbors. I guess I can put this to the right. I'll put this over here. And let's just see if I can make this a little bit bigger. And we can sort of follow along visually as we go through this. So all we've done so far is we've started this path and we've added this current start tile, and then we go visit neighbors. and we go through all of the tiles and we say, are you in our path? None of the tiles will be in our path right now. And then we say, are any of these tiles our neighbors? And we say this tile is a neighbor. Cool. So what we do here is we add it, or we create a new path that's a copy of the one we're on. We add the new tile, and then we check, is this the end tile? It is not the end tile. Remember, the end tile is the one over here. This is the end. And because it's not the end tile, we say visit neighbors again. So we pop back at the top and we get the coordinates for this tile now. And we grab all of the coordinates of our neighbor tiles and we iterate over all the tiles. And one thing you'll note is we will find the start tile as one of our neighbors. So we'll bump into this, except in this case, does contain coordinates will return true. Because we do contain it, we'll just continue. And what continue does is it just puts us back to the beginning of this for loop. So it doesn't run any of this code after it. Okay. The next thing we'll do is we'll visit this tile and we'll say, hey, that tile to the north, we haven't visited it yet. So what we'll do is we'll make a copy of our path. We'll add the tile to the north, and then it's not our end coordinates. So we'll visit all of the neighbors. And so we'll visit the neighbors here, and then this keeps going on and on and on until we get here. And then in one iteration, we'll visit the end tile, and in another iteration, we'll visit here. And when we're on this tile with this path, I'm just going to draw it again in purple, this one right here. There will be no more neighbor tiles that haven't been visited, so we'll end up just fizzling out of this function. Then additionally, and this is the tricky part about recursive functions, is remember a while ago when we visited this north tile, we ended up going deeper in our recursion and doing that path. But there was also another tile that we hadn't visited yet. So once the first recursive function set finishes, it'll have found a path and it'll have negated another path, and then we'll visit this tile, we'll visit this tile, we'll visit this, which makes a path, and we'll add it here because it's the end coordinates. But then we'll additionally go up, over, down, and when we reach this path, which I'll draw here in purple, we'll have no neighbors that we haven't visited already and will not be at the end coordinates, so it'll also just sort of fizzle out. Okay, so that is our pathfinding algorithm. I highly recommend just looking over it and maybe even running the game and stepping through it and getting a feel for what's really going on there. And that sort of problem solving where you use a recursive function is typically not obvious. And I did spend about an hour thinking about this and writing stuff down on paper to try not to use a recursive function to find the solution, but I wasn't able to find or create a very obvious algorithm that does this without recursion. So if you did find a way to do this without recursion, please share it with me. I'd love to know. But right now we're just trying to get something that works. So let's go and visit the other two things that we had in our game. So when we're updating the game, and that's how you spell game, if we have less than the maximum number of monsters, we want to spawn one. So let's get to that part. We just go to our game update. Maybe it's update play. And we will say if the number of enemies we have is less than, some number of enemies, I max enemies, then we need to spawn an enemy. And let's just make some random number here. Sure, let's do 5. That's fine. We'll do 5. Then we'll do spawn enemy. So what we want to do is we will say entity ampersand new enemy is in place back enemies. And right now we have passing in the enemy template. I don't actually know if that will work. That seems a little spooky. It does compile, which is sort of weird. I don't remember creating a default copy constructor for this, but maybe, I think actually C++20 does allow you to have default constructors like that. Let me look to see if there's anything that's not trivially copyable that would screw us over. So all it is sprite and physics data. And physics data is just shapes, which is an enum, type, which is an enum, floats, SF vector to F, and entities to ignore, which is all good. So I actually think this will work, but what we might want to do here is we will take our enemy template and we will set the position to let's say this. We'll say if we have a spawn tile, so if we have a spawn tile, we will set the enemy template's position to the spawn tile's position. So we'll go spawn tile 0 dot get position. And what this should do is it should say if we have a spawn tile, we'll set the template's position to 0. And then when we add the enemy's position should be the spawn tile's position. So now when we run this, we'll first have no enemies because we don't have a spawn tile. But if we go and add a spawn tile here and then we go back out, we'll see all of our enemies spawn there, which is pretty cool. And then additionally, so this sort of checks off the first part of our list. So this is done if the number of enemies is less than the max, we spawn it. And then what we need to do is we need to give the enemies a path to follow. So one thing that is probably pretty important is we don't want to just check, hey, do we have spawn tiles? What we also want to say is, do we have a path to follow? So we need to say the number of paths we have, make sure it's not empty. We don't want it to be empty. And then do we have any random numbers? Do we have any, what are we using for random? Standard rand. Okay, that's fine. Let's go back to our enemies. What we want to do here is we want to add a path for them to follow. So just simple. I'm going to add a note to myself because I'm going to add some information to the entity that I don't think should live there forever, because it's going to live on all entities, not just enemies. But just for the sake of this tutorial in game, it's just much easier if we just toss this onto the entity itself. So what I'm going to say is just a note to myself, stuff that should probably be moved somewhere so that it is exclusive to enemies. And then I'm going to have an integer, and I'm going to say I path index. And then I'm going to have another integer, I current, well, okay, it's a little confusing, but what I want to do is I want to have one integer that tells me which path I'm using, and then another integer that tells me which index on the path I'm using. Although I actually don't know if the second one's going to be as useful, because like I said earlier, what I'd ultimately like this to be is more of a physicsy sort of game. So I actually think that we won't just be able to use the current path index. What we'll probably need is a more dynamic solution where we find the point on the path that we're closest to, and then we go to the next point that that points to. So what I'm just going to do is keep this as a path index. And then I'm just going to add a function here called setPathIndex that just takes in an integer and sets the path index. And then in here, when I have an enemy, I am going to set the path index to a random value on the path, or a random index for our path. So if our path size is 1, you can do this trick where you just get a random number and you modulo the size of, or the number of options you have. So size will be the number of options we have. If we have 3 paths, the size will be 3. So if you modulo 3, you'll end up getting a number between 0 and 2 inclusive, 0, 1, or 2, which will point to the path that we have. And then the next thing, well, there's 2 things I'd like to do actually. Every time we construct the path, or actually not every time we construct the path, whenever we when we're in level editor mode, update level editor, right? When we're in level editor mode, how does this handle this? Handle input. Okay. When we're in level editor mode, I just want to clear our list of enemies, because the information that was associated with the list of enemies was for whatever level we were running when we were in play mode. But once we're in level editor mode, we could change the spawn. We could change the spawn points. We could change the paths. We could change the endpoints. We could change anything. And so if the enemies are holding on to this information, like the path index, that might become stale if we go back into the level editor mode. And it's also kind of convenient to just be able to go back into the level editor mode, change all of our paths around, and then when we go back into play mode, all the enemies spawn fresh and we get to see what that looks like. So I'm going to add this here, and then in our gameplay, or I guess it's play update play. Okay, lovely. What we're going to do here, besides spawning enemies, is we need to set the velocity for all of the enemies. So what we'll do is we'll say for entity reference our enemy in our enemies, we need to find the oh, this is sort of what we want. Let's see what this gave us. We want to, get path index. Yeah, we should add a get for this. Get path index. We want to get the path. So let's write some comments here. We want to get the path that the enemy is on. The path size should be guaranteed to be greater than 1, because we'll never do a path without a starting index. And then we want to find the current tile, although I don't think it's going to be this trivial to find the current tile, because we don't actually want to do current path index. What we actually need to do is we need to say for path tile in the path. No. What we want to do is we need to find the closest path tile to the enemy. Path, just a list of path tiles. So we will say path tile, the closest path. And then, yeah, this is pretty common. So we'll keep track of the closest distance, and we'll set that initially to some huge float value. And then what we'll do is we'll iterate through all of the paths, and we will find the distance from the enemy to this path tile. Do I have a length function? Is that true? Did I write that? I did. Nice. So we'll take the current tile's position minus the enemy's. Did I write enemy like that? Enemy does not have an E there. So we'll say enemy. Okay. Enemy to path tile, we'll get the distance. If the distance is less than the closest distance, then we'll set the closest distance to the current distance. We'll set the path tile to the current path tile. And then what we're going to do is we actually want to find the next tile. So we first find the tile we're closest to. So find the closest path tile, and then find the next path tile. And the next tile is going to be the closest tile's neighbor. So we say closest tile, and then we say next tile. Oh, of course. So we go to path tiles. No. It should be right. Yeah. Why is it not happy here? A reference cannot be initialized with the value of type const entity. Because this is a const. Oh, yes, of course. This is a entity pointer. Next tile. So now we have this next tile. And what we want to do is we want to find the direction from the enemy to the next tile. Then we're going to normalize that value. We're going to multiply it by the speed and set it as the velocity, which is more or less what we were doing before. But before we were always having it move towards the player. Now we want to have it move towards the next tile. So I'm going to copy and paste what we had before, and let's just sort of follow along. So we don't need enemy to player. We need enemy to next tile. So what we can do instead is we'll have v enemy to next tile, which is going to be the next tile get position minus, not the enemy template. Now it will be our enemy dot get position. And then what we need to do is we need to normalize that value. So we will normalize it. And then the final thing we need to do is we need to take the enemy and we need to set their velocity as that normalized direction from us to the next tile times our speed. And then we don't need any of this other stuff because we're not keeping track of the next tile we need to go to. Instead, we're just going to calculate it every single time. And that's important because when this does become more physicsy, you can imagine that if an enemy is somewhere along the path, we could knock them back all the way to the beginning, and we need them to dynamically be able to say, hey, this is the new closest tile. I'm going to go to the next one still. And this looks all good. Let me go back to my notes real quick. Oh, and then if the enemy is at the end, we need to delete it. So that's the last thing that we need to do. So we can add a little check here. Let's just do that. We'll say, well, okay. So we can do here instead is we can say for, instead of just doing this for loop, we can say for an I equals 0, I is less than, well, okay, let's do this. I is enemies dot size minus 1. I is greater than or equal to 0 minus I. We're going to go through the array of enemies backwards because if we do find an enemy that is close enough to the end to call it, we're going to delete that enemy right away. And then we'll have the same thing here. We'll have this const. It's not going to be a const, but we'll have an enemy. Holy cow. Entity reference enemy, which we'll set to this. And this should just be, it's a legitimate list of enemies. Oh, sorry. All right, let's power through to the end here. So we have an enemy, the path tile, current path tile. Okay, and we find the next path tile, next tile. What we can say is if next tile get closest grid coordinates equals end tiles get closest grid coordinates, then we can erase this enemy and continue. Well, maybe we don't want to do this exactly. What we want to say is if the next tile is the end tile and our distance to that is less than 40, then we'll erase it. We don't want to erase it just when our next tile is the end tile, because we'll erase things before they really get to the end tile. And then finally, what I would like to do here, nope, this is all good. Let's run this and see if it compiles. And then we'll go into the level editor mode. We'll create a start here, oops, an end here, and a path. And we'll leave level editor mode, and nothing works. Let's see what we're getting hung up on. Do we have any paths? No paths. Okay, no problem. I do remember. So we need to add a path at the end, and we break. Okay, one thing that we need to add here that if you ran the game, you will have crashed is that I forgot to set the next tile when we're traversing. So when we're visiting our neighbors, if we find a neighbor that we haven't visited yet, and we copy the path, the first thing that we're going to need to do with this new path is say new path dot back dot next tile, and we need to set the next tile to the next path tile, and then now this should work. So we go back into level editor mode, we create a start tile, we create an end tile, we create a path, ensuring that we make a path node on the end tile. Then we leave the mode and we see these guys spawn in and start heading towards the end. And we'll sit patiently for a moment and see if they make it there. You'll notice also that we spawned everybody at the same time, but they're not overlapping. I believe that's because they're still respecting each other's physics, which is fine. And then hopefully when they get to the end, they start popping back out. Nice. And then the only thing I'm going to change real quick just for testing is that this enemy speed is a little slow for testing. So if I change this up to 250 and I go back into level editor mode, start here, I'm just going to put an end here and a path that goes like this. Leave the mode. Let's see what this looks like. Not too bad. I'm going to go back into level editor mode and add in a different path. We'll see if this works. So about 50% of them should go up. Oh, and it looks like all of them are going up. So that's not great. Oh, there we go. So I suppose they all just picked that the first time. Cool. And then let's add one more path. And maybe even one more path. See what this looks like. Oh, and that's fun. I actually kind of like that. I didn't think about that. When you have something this complicated, you can actually have some paths to the end that do double back a little bit, but are kind of interesting. So that path, it looked like it was going here, then up north, over, down, over, up, and then towards the end. And just to add a little bit of aesthetics here, I suppose. Actually, now that I'm looking at this, it is a little annoying that you can't draw the aesthetics with the path here, because you kind of want to draw the aesthetics around the path. That's sort of the whole point. So maybe I should add, all right, I'm going to do, instead of saying level editor mode, when we draw the level, instead of saying if the tile type doesn't equal aesthetic, what I'm going to do instead is when we handle the input, we say if you press T, do this. So I'm just going to add a new one here that says what's a letter next to T? We'll do Y. Was Y pressed last update? Do Y there. If you pressed Y, if y was not pressed last update, what we'll do is we will add a Boolean here, and we'll say draw path. We'll default that to true. Where was that at? It's after everything. So we'll say draw path to true. But if you press Y, handle input, there we go. If Y was not pressed last update, then we will draw path like that. And then in the level editor, when we're drawing the level editor, we will say if draw path, then we draw the path, else don't draw the path. So now we go into level editor and we go to start, and we can click Y to toggle if we're drawing the path or not. I'm going to draw the end tile here, and I'm going to draw the path. I'm going to draw one that goes up and over. Need to make sure it closes. One that goes like this, and it's actually probably okay if we have like weird parts of the path like that. And then additionally, I'm going to draw some rocks or whatever this is around the spots that are not path. Just a little visual. And then I'm going to draw blue on the start and red on the end and green in between. I guess I don't need to draw the path now, so draw this green. Dun, dun, dun. And then we'll exit level editor mode. Actually, I want to make this a little bit prettier. Draw that. Exit level editor mode. Duh. Okay. And this is one caveat here. So I sort of forgot. These are not just aesthetic tiles. These are real tiles. So I'm going to delete the path now, and we'll or the glowing and stuff, and we'll just leave these the bricks around the edge. So let's look at what this looks like. Oh, you can see them kind of bumping into each other, which is fine with me, and they kind of get to the end. Yeah. Oh, all right. And yeah, thanks so much for watching. I think we're going to call it there. This is sort of what I envisioned and a little bit different than what I envisioned when we first set off for this. We've got a loose physics-based pathfinding tower defense sort of setup here, and there's probably a lot of fun things we can do from this as a starting point. Yeah. And if you enjoyed this video, it really mean a lot to me if you left a comment, like if you liked it, subscribe if you want to see more, and yeah, thanks so much.